My name is Warren Kavanagh, and this is my submission for the data capture and messaging portion of the IoT module for DTO21A Year 4. The purpose of this assignment then is to build this network topology, incorporating a sensory device layer, a gateway layer, and a cloud layer. So our sensory device will be our BBC microbit. The function of the sensory device then will be to convert real-world analog signals into digital signals using the sensory devices located on the BBC microbit. From this then, the information captured on the BBC microbit will be transported onto the gateway layer using a Bluetooth connection to our gateway device being the Raspberry Pi. The Raspberry Pi then has more computing power than our sensory device, which is a low energy device, and the information captured from the BBC microbit can be further processed and used in a meaningful way. The gateway device is also acting as a networking device which transports this data captured by the BBC microbit to the cloud layer. And the cloud communication protocol used within this assignment is MQTT, which is built upon the publish subscribe method. The gateway device then being the Raspberry Pi. So as it's over a Bluetooth connection, this will be our gateway device, will be our central device, and then our sensory device layer, these will be peripheral devices. And as it's over the Bluetooth connection, a central device can connect to multiple peripheral devices. So this gateway device, the Raspberry Pi, even though in this assignment we're only using it with one connection, it could be connected to multiple sensors down here. And these are all transmitting data up to our gateway device. And then the gateway device has a higher computing power, so data from the sensors can be further processed in a meaningful way. And then once it's processed, it can be switched on and transferred to the cloud layer. So the cloud layer then uses the MQTT protocol, which is the message queuing telemetry transport protocol. And within the MQTT cloud server is an MQTT broker. And the function of the MQTT broker is to receive messages from devices and then transfer them on through the cloud, through other devices. The MQTT broker breaks up into several topics. So examples of topic could be accelerometer, magnetometer, and LED topic containing information on particular sensors. So how the publish subscribe method works within the MQTT protocol. Device B over here could subscribe to the accelerometer topic, indicating that it wants to receive information on the accelerometer topic. When device A then publishes information to the accelerometer topic, so this could be the values of the accelerometer that this gateway device is connected to, being our BBC microbit. As a gateway device B is subscribed to this topic, it will receive an update saying that the accelerometer topic has been updated, and it will receive the value of what the new message received on the accelerometer topic is. And this is how devices can communicate with each other through a cloud server. Within the NodeJS script then, we first have to import the modules Noble and MQTT to be used inside the script. Once they're imported, then we can connect to our MQTT broker using the MQTT.connect function. And the two topics defined here that we want to subscribe and publish to are the magnetometer and accelerometer topics. There's just a bit of Bluetooth related setup then. We're just defining each of the UUIDs that we want to connect to for the actual BBC microbit UUID, and then each of the services UUIDs and the characteristics UUIDs. So these are the identifying features that we want to read. How Node.js works then, it waits for events to occur, and then on these events it will call a callback function. So you can see here on a state change event, we want to call the state change event handler callback function. On a connect event for the MQTT client, we want to call the MQTT callback function, and this just defines how to handle this event. So for the state change event, if we're powered on, meaning that the Raspberry Pi is running the program, we want to start scanning for Bluetooth enabled devices with service of interest UUIDs associated with them. For the MQTT connect callback, we want to subscribe to our two topics, our Excel topic and our magnetometer topic. On a discover event, meaning that a Bluetooth enabled device has been discovered, we'll call our discover device event handler. What this does, it checks if the peripheral of interest is the UUID associated. So the UUID associated with the BBC microbit found is the peripheral of interest UUID, and if it is, it will connect to this peripheral. So the Raspberry Pi will connect to this BBC microbit and call the connect callback function. Once the connect callback function then is called, the services associated with this peripheral need to be discovered, and we only want to discover the service of interest UUIDs defined at the beginning of the program, and it will call a callback function once these services are discovered, called discover services callback. This discover services callback will iterate through each of these services and discover the characteristics associated with these services. Once the characteristics are discovered, it will call the discover cars callback function, and this is broken up into accelerometer characteristic, magnetometer characteristics, button characteristics, and LED characteristics. So if an accelerometer or magnetometer characteristic is found, it will be read every half a second, and a job will be put on the stack to read this characteristic every half a second using this read cars function. If a button characteristic is found, we want to subscribe to this button characteristic, and when we subscribe to this button characteristic, a data event will occur if this button value changes, and we will need to tell on this value changing. We want to call this data callback function. The LED characteristic then is just stored in this LED car variable, which will be used later on to read and write to the LED. On a message event from the MQTT client, so this means a message has been published to the topics we've subscribed to, being the accelerometer topic and the magnetometer topic. We want to call this message event handler. What this message event handler does, it will print out the message that has been received on the topic, and then it will flash the LED on, writing a value of 1 to it, and then flash the LED off, writing a value of 0. So from looking at the BBC microbit, we can know if it is communicating with the MQTT topics and receiving messages. And then this write data callback function is used when a value is written to the LED characteristic. It's defined down here. This BLE subscribe callback then is used when we have subscribed to the button characteristic, and it just says notifications are enabled if the subscription is successful. On data then, so this is what happens. This is the function that will be called when the button changes state as we're subscribed to the button. So we're just testing here, if the button state is a value of 1, we want to loop through the accelerometer characteristics and the magnetometer characteristics. What we want to do is read each of these characteristics, and there's two callback functions used, a read Excel data callback and a read mag data callback. And if we go down further, what these two functions do is they publish the value read of the characteristic to associated topic. So for the magnetometer, it will publish it to the mag topic, the value of this characteristic. And for the accelerometer, it will publish it to the accelerometer topic, the value of this characteristic. This read cars function then is the function which is called every half a second, regardless if the button is pressed. And again, this just calls the read mag data callback for the magnetometer characteristics and the read excel data callback for the accelerometer characteristic, publishing the values to either the excel topic or the magnetometer topic. The publish callback then is just used is just called when a publish a topic or a data value is published to a certain topic, and yeah, it's commented out here now, but you could use this function to indicate that a message is successfully published to a given topic. To run the script then, we first have to set up an MQTT broker on the MQTT website HiveMQ. And we have to subscribe to our Excel topic and our magnetometer topic to ensure communication between the Raspberry Pi and the MQTT broker. Once this is implemented then, we can run the script from the command line. Just need to navigate to the script. So the script name is Warren Cabinet Assignment 2, and we can run it using sudo node Warren Cabinet Assignment 2. Now the script has started running and we've started scanning for devices, and we've already picked up our device. There is with our UUID, and each of our services, our characteristics have been discovered. The accelerometer, the magnetometer, button A, and the LED. And you can see here on the left that it's already started transmitting to the MQTT broker. And as we're subscribed to it, we're also seeing it over here. So received message, magnetometer or accelerometer value from device, Warren BBC on mag topic or Excel topic. If we want then to press the button on the BBC microbit to implement the manual read feature. So we hold it down, you can see there, manual read executed, and it will transmit the data of the magnetometer and the accelerometer sensor to the MQTT broker. So I click it once or twice there, and it should, there you go, seeing manual read executed. Just to show the LED write characteristic then from the Raspberry Pi. So the accelerometer and magnetometer values will be transmitted and updated every 5 seconds. And this can be indicated by the flashing LED as the Raspberry Pi is subscribed to the accelerometer and magnetometer topic. The manual write then can be executed by clicking button A and holding it in. The other LED is indicating there, showing that button A is pressed, and then we're writing values out, which can be seen on the HiveMQ website to the left.